Champions! Got another Yami to look at. This one is a bit not as high end as the last one we did. It's the CA-610. So, it's in the Natural Sound series. It's got the similar hardware on the front there, same sort of looking switches. So first thing I noticed was volume knob, although it is turning, is really loose. So I think something's either come loose or it's broken in there. Depending on that part, that could be a bit of a showstopper. So I'll check that out first. The unit is not as good shape as the last one, but pretty good considering its age. This has got the fake vinyl stuff, not the real veneer, and it's starting to peel off in a few spots. But the top's in not bad shape. A little bit of peeling there as well. Same old situation on the back here with the heavily corroded input RCA sockets and the obligatory build-up of shmoo on the speaker output terminals. It's passé by Kinamini. So yeah, I'm not sure the vintage of this one. I'll look that up compared to the other one. I think it's late 70s, maybe a little bit earlier than the last one. There's just a few things on there that you can see. That is pressed steel. The other one is plastic, moulded. So they made a few advancements over the years, I think, in terms of technology and making stuff cheaper but still good. Meters are a bit smaller. Blah 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 blah. Anyway, well, let's crack this thing open and see what's going on. Alright, so this one is somewhat more ghetto than the last one. It's a trailer park cousin. So it's got sort of one main circuit board down the bottom, another circuit board at the back, which looks like an extension in this one, but there's actually a join in the middle of them. There's your output devices mounted on a heatsink, otherwise known as a plate of metal, which isn't much of a heatsink. So there's another board up the front here, which has a couple of switches. That's the EQ board. There's the healthy layer of pubes all over everything, like you get with every vintage amp. It's just dust, and because they've got greased mechanisms, of course it sticks to it like shit to a blanket. And that's right under the vents, so you see that's sort of there, that's sort of there. So the front section's not too bad, needs a bit of a clean up, but the back where the vents are is really where all the crap gets in there. So we'll give that a good old clean. Looks like a little bit of tobacco helping everything stick to it perhaps. And we'll flip it over and have a look at the condition of the solder joints on the bottom of the board. But I'd say this is another contender for a full recap. Much smaller caps, 45 volts, 6800 than the last one. There's not a hell of a lot of caps in there, most are small. It's just those two ones which are medium ticket items, but they're probably, I don't know, $12 each or something. And being that they're not chassis caps, we'll be able to replace them reasonably easily. All we've really got to do, all the new caps are going to be smaller diameter, so all we've really got to do is check the lead spacing and try and get something as close as we can. So good news on the volume control, flopping around. It's actually the whole pot that's flopping around, so it's not like the shafts come loose in the pot and we've got to throw the pots out or anything. So that's a pretty old school dual gang pot there, almost like two pots joined up. And you can see, if the camera plays the game, in there, it's sort of hard to see, but the nuts just come loose. So there's no lock washer on there. So it's got spring washer, so it's got the locating key. But there's nothing to really put any pressure on that nut. So it's relying on basically the flex of itself to hold itself in place under torque. Anyway, we'll flip it over and have a look at the solder connections. Well, there's nothing too scabby on this one. It's all wave soldered like all of them, so you got that big shiny layer of flux all over everything. You can see it's uneven. That's the flux that's in the solder, which is literally like a wave machine like you surf on, but out of molten lead. So not that fun to surf on, and the board passes over it with all the components installed, and the solder basically just stays wherever there's a pad and component lead. And that was the way stuff used to be assembled, all the through hole stuff. I think some of the really low end stuff is still wave soldered, but mostly it's pick and place and reflow these days for surface mount stuff. There's the few connections, 5 little link wires there, kind of an old school way of doing things. And there's a split in the board there. They've drilled a few holes that go through to allow airflow around the heatsink, and a few little bodged in caps there, probably RF interference bodges to improve rejection, grounded to the chassis there, or oscillation or something, but yeah, that's definitely factory. So we might just go ahead and fire it up and just see what's going on sound wise, see if there's any DC on the outputs, see if there's much noise on the power rails. I kind of just want to go ahead and quote them for a recap on this. I might ask them what their budget is, and if it's over a certain amount, we'll just go, yeah, okay, well, you're getting a quote for a recap, because these things often have been switched on their whole life and the caps are all shot, and if they're not shot yet, you're super lucky, and I'll be less lucky when you come back in a couple of months and want a free recap because it's failed. So yeah, that's why sometimes us techs decide to do a full recap or nothing, because it's maybe outside the warranty, but not in the customer's mind it is not, so you have dramas. Anywho, on a side note, isn't this cool? So you've got little dotted lines there on the circuit board. They've basically divided the circuit board up into sections that each have a purpose. So that's the main right channel. Yeah, well, that's the amp, because there's the emitter resistors, 0.47. They're playing it safe. And there's the meter driver circuit, all isolated in that little dotted box there. The left channel, main left channel protection circuitry. It tells you on the circuit board what you're looking at. That's something. I should send this video to Mesa Boogie. And here you go. Before you guys were even in business, these guys knew how to lay out a board. Yeah, very cool. So you can see there's not many caps there. So I'm just going to say stuff it and just fire off a quote for a full recap, as well as a clean and service. The clean and service is the majority of the work. Because this is a cool old amp where the bottom's removable, there's really not a lot of labour in the actual recap itself. There's probably still an hour in it, including, ordering the parts and ordering the parts, documenting which ones are which, just the admin involved, and then it looks a bit bulgy. That's just the disc on top, and then just replacing them. So there's probably an hour in that, in addition to the usual service. But yeah, these amps they require a bit of work, but really the work's doable. So they're worth picking up, these things. If the board's not conductive, ask me how I know. They're generally pretty viable to restore, and kind of fun, really, if you're a fucking weirdo like me. Champions, I messed up on this one. Not the amp, the video. I recorded the whole process of cleaning it and changing all the caps and doing all the bits and pieces, changing the light bulbs, and went back to see where I was at to continue recording the videos, and there's no audio. So OBS, Open Broadcaster, seems like every time you start it changes settings, like just random stuff that you never even touch. It just chooses random arbitrary settings and sets it to that every now and then when you start it up. I didn't change anything, and all of a sudden the audio source was set to something that had no signal on it. So, yay! Even got to troubleshoot my bloody software. So, there was all these videos of me really exuberantly going through things and explaining stuff, and there's no audio, so it all got thrown straight in the recycle bin. So anyway, just trust me, I recapped it. So we've got new 105 degree caps everywhere. We've got 2 CDEs there, and everything else is Nichicon. We've got 2 bipolar ones at the front, which I forgot about and had to order afterwards. And we've replaced the 2 bulbs for the meters with new, just incandescent anyway, to get that nice glow. I could have gone LED and messed around and put resistors in line and calculated and stuff and tried to silicon them, but they'll probably last 10 years at least, and if they blow up again, it's another $20 to replace them. So we're going to fire it up. We've given the circuit board and everything a clean, the contacts. I've got to tighten this this knob at the front here, the volume knob still, so I've got to remove the faceplate, and to remove the faceplate I've got to remove all the knobs. So we'll do that. They've got a set screw at the bottom with a Allen key grub screw. I'll just grab one of them. This often happens when I leave it a few days between jobs or a week between jobs waiting for parts to turn up. I forget where I'm at with the video. Trying to maintain some kind of continuity to an edited video can be difficult if there's crossing between different jobs, waiting for parts, juggling different projects at once. So you've got to go back and watch the video, figure out where you're even at, what you were talking about, what your point was. Oh, that loudness switch is almost completely jammed. Wow, really gummy. Everything else is alright, it's just that one loudness switch. I'm wondering if someone's lubricated that with something unsuitable in the past and now it's gummed up. But yeah, you've got to remove all the knobs. You've got to remove this knob, which means we've got to get in the side here. There's a little gap between the faceplate and the chassis. And the set screws on there to remove the knob on the front. Now, on the last one this was really tight, and it looks like it is on this one too. Like unnervingly tight. That's because there's 2 set screws. I'm with it today. I've been doing paperwork all morning. Oh, so that should come out now. Yep, and it does. That's a solid chunk of alley. It's really, really nice. You find on the cheaper stereo. Oh, no, you don't have to remove the faceplate. So I could have left all those other knobs on, but it helps us clean the front panel anyway, because the nut is accessible through an enlarged hole there. Duh. What was I saying? Oh, some of the cheaper units as they pushed into the 80s and 90s and stopped having to make things so chunky. Everything was circuit board mounted, small pots, small diameter switches and everything. Everything started to feel cheaper, so what they did with, they'd add artificial mass to things. So it's quite common, you'd open it up, you'd find your volume knob on the front, it's just plastic, maybe a really thin little can of alley, machined alley over it. And then inside, there's literally a big chunk of iron, shitty cast iron, that's bolted to the same shaft, and it adds weight to the turning, so it feels more expensive, like you're turning a big friggin' Variac or something to change your volume, like Marty McFly at the start of Back to the Future. So it's all this psychosomatic bloody, I paid a lot for this thing, so it's got to be skookum as free, so let's make everything heavy unnecessarily. It's like those Beats Dr. Dre headphones. They've actually got rings of steel inside them that do nothing except make them feel heavy and expensive, even though they're the worst sounding pieces of shit I've ever heard. Anyway, No account for fashion, eh? So, we'll tighten up this pot. You can see through there, there's a little gap. Ah, and of course it's the socket that's not there. What's that, 10 mil? No, we want 11. Go. What I might do, put a lock washer on it. Seems pretty logical, doesn't it? This is a bit where I lose the nut down inside the chassis. No, we got it. So there's the crazy pot. It's got a tap there as well. No, maybe it's just the design of the thing. No, there's definitely 4 contacts per channel. So it's got a tap there for some reason. I'll have a look at that on the schematic. For now, I'll just put a small lock washer on there, a star washer. What size we got? Metric, yep. That's not cross-threaded, eh? Gotcha. Should stay tight forever and ever now. So we're about at the point where we could fire it up, give it a quick test, and we'll put it under sustained testing once we've confirmed that everything's operating as it should and it's putting out full power, just to make sure there's no board conduction or anything weird like that. But before we do that, we'll do a little bit of cleaning. Just go the normal brush. Okay, so the first thing we're going to do is get out the variac. And we're going to test for DC on the outputs. But before we do that, we're just going to do a quick diode test of the output devices, which I've done before, but that's the first thing I do when an amp comes in, just check that the output's not shorted. But we'll double check, just for your viewing pleasure. No shorts there. Eat my shorts. So we'll also just double check these fuses are sweet. That one's good. That one's good. Check the bridge rack for shorts. no shorts. And now we fire it up. Oh fuck. Get our Variac boy, turn it on, and watch the current draw. 6 watts, but uses 6 watts with nothing plugged into it as well. And that's on. Slowly raising the voltage, only up to 8 watts, 9 watts, 10 watts. Something went click. 12 watts. LED's lit. 14 watts. 15. 16. We're not showing severe DC on the outputs. We're up to 200 and we're drawing 20 watts. So I think everything's cool. So let's hook it up to the scope, feed it some signal at full power, and we'll see how she do. Okay, so now we're connected directly to the mains. Click her on, and no smoke. The relay clicked there, so the protection's not engaging. Drawing 19 watts idle. And bugger all DC. We've got 17 millivolts and 7 millivolts DC on the outputs. So we'll turn that off again, and we'll check the idle current. So to do that, there's 4 test points on the board. There's 2 for each side. May as well do 2 at once, eh? Steal our multimeters back. Just unplug it to be safe. Alright, left channel. I like leaving the little Velcro on the things. Keeps your desk a bit more organised. Millivolt, millivolt. Negative to test point 3 on the right. Positive to test point 4 on the right. Negative to test point 1 on the left. A little bit tight in there. Positive to test point 2 on the left. We can still get to that trim pot, can we? Yep. Alright, let's give it a go. Let's see those meters. Yeah, so that's set to millivolts. Now the spec is 11 millivolts per side, plus minus 2 millivolts. So we'll adjust it to that. Start on the left. Good if my screwdriver fits. Good if that one fit too. Third time's the charm, eh? No, that's tiny. This one's got to fit. Alright. So turn that anti-clockwise and it's going down. So we'll aim for 11. It seems pretty responsive. Nice and gradual. It's a well-designed circuit. Some of them are real twitchy. because they don't have series resistances to set basically the window of opportunity for the pot. So they're real jumpy, and if you turn one way, it's dramatically out. So we'll leave it there for a bit. We'll keep an eye on it as it warms up. We'll watch the current draw too. That's gone down to 16 watts, of course, because if we turn down the output stage dissipation, as we turn that up again, you can watch the output dance around with it. The mains draw, I mean the input. That's pretty close there. Let it warm up. Let's see if it drifts. Alright, so we've had that idling for about an hour now, and it's only drifted up by about 1 millivolt. So we may as well just bring that back down again, just for shits and snickers. Helps if you take it out of max mode. Come back to 11 millivolts. And we're there. We'll power it back down again. We'll give it some signal. Check its noise floor. Check what it sounds like, and then carry on with just doing the front panel clean and get it ready to put back together. Alright, so I've moved over to my other bench here, migrated the test setup. I've got to do a bit of service to that signal generator. It's a little bit intermittent, so not to be trusted, and I've rearranged some stuff and haven't plugged it all back in yet. So we're over to the right goal. We've got our 2 probes attached to 2 8-ohm 100-watt dummy loads there, screwed to the wall. Bit of a janky setup, but it does the job and stays out of the way. We've got that hooked up to the amp. We've got a little USB thing there. I like to screen print the power readout at the onset of clipping, just to show them that the amp is capable, and copy that with the invoice. So we've stabilised at 16 watts again, which is what we had before, so that's good. It's always handy to have these watt meters. They're like $50 each or something. I just have them on each output of the test bench, and you'll know straight away if something goes wrong by them being off the charts or not what you were looking at before. So we've got the signal Jenny here, and haven't bothered calibrating the input. It's probably about a volt. So we'll turn up the volume, and one channel's coming up but not the other. So why is that? First thing to check is the probes. Yeah, so I've got one set to times 10, one set to times 1, and the scope set to times 10. Analog scopes, they have 2 readings there. So one's for 1x, one's for 10x, and it's got the appropriate readouts there on the skirt of the knob. But on digital, you've got to enter that, which one's which, 10 or 1, and stick to it. So we could go 1 times for this, whatever. But yeah, we'll go 10 because that's what it's at. That's putting out 17, 18 volts. Where scale's a little bit low there. I'll just change it up. Change it to 20 volts. Channel 2, channel 1. 20 volts. Try again. A little bit crackly there on the volume. Oh. Is that crackling or oscillation? Whatever it is, it's not polite. 21 volts at onset of clipping. So what's that? 21. Got 8 ohm load, both channels driven. say 21 volts, 20, we'll go 20 to be conservative. 20 squared divided by 8. 50 watts a channel. So I've attenuated the function generator so we can see what the upper end of the volume control is like. Now, when these are turned up, they generally only go to 2 or 3 on average. It's beyond, say, 5. That's really cranked. That's not your usual home hi-fi use unless it's a party house, which it's never below 10. So that whole second half of the pot often doesn't get used much and doesn't get wiped. The wipers don't wipe on the track as much as it would for the below 5. So you often find that these pots are very scratchy above 5, and they come good with the clean. So what we thought was oscillation a second ago, I'm pretty confident it's just that right hand. So that's not showing the signature that you'd expect to see from oscillation. That's showing intermittency from the pot being scratchy. And now we're up in the top range of the pot. We can see that. So that's the left hand scratching, because that's the one the scope's triggering off. It makes it look like there's a problem on the right channel as well, but the right channel's a little bit cleaning up now after using it a few times. So we'll give that a clean and see if it comes good. I use this stuff here, Electro Lube, contact cleaner and lubricants. Don't just use the contact cleaner. You need one that re-lubricates, otherwise you'll wear the pots out. There are better ones out there. I've got to get some, I think it's Deoxit Fader Lube, D something, D5 or something. I've got to get some of that. It's pretty expensive, but it's a bit thicker. It's good for open faders, that kind of thing. So we'll just get in there, in the little hole. You see there's a little vent there. That gives you access to the wiper, and really you want to be very sparing with this stuff, because I often open up amps and there's a big pool of it on the board. We'll see how that goes. Give it a few wipes back and forth. We can already see there that that's smoothed it right out, so all that scratchiness is gone. We'll let that flash off a bit, and then we'll give it another run. I'll just test the bottom half of that pot range now by letting go of that attenuator. And it's nice and smooth. It's good. So we'll do that with all the pots and switches, and should probably be a nice quiet amp after that. And then we'll fire it up and have a listen and see how it goes, and blah blah blah. Alright, so we made a few tweaks to the levels. We can fire it up full scale. It triggers there. And it's happily pushing into clipping with no oscillation, so what we were saying before was just dirty pots. Happy days. Now it's time for a bit of gleeful knob polishing. And once again, you only want to use just a slightly damp rag to clean these face panels. You don't want to risk taking off that silk screen. Just start with the most gentle thing first, which is plain water. And if that works, there's no need to go for anything harder, eh? Try the most inert cleaning fluid first and see if that works, and work your way up, only if you have to. But yeah, wouldn't be using anything too aggressive on this silk screening, particularly this old. It's just going to come straight off. You don't really want to see a vintage amp with Dymo labels all over it. Although that would look kind of cool, like a prototype or something. Here we go, she's all clean now. Don't they look gorgeous, these things? I love the anodized alley look. And I had a look online for these, not the 610, but the CA and the SA series, and they're going for like $1,000 to $2,000, and that's like, I've got no idea what the condition inside them is. I don't know if they've been recapped or anything. All that'll have to be done. But on eBay and even on the sold listings, like in Japan, they're going for heaps of money. So really, it is worth fixing these things up.
1, 2,